Hello dear students, today we learn the analyze the fixed beam and draw the BMD and the SFD. Now suppose this is a beam AB is subjected to partial dual which is from the 2 to 8 meters, okay, which is starting point is 2 meter and end point is a 6 meter, 4 plus 2 6 meter, okay. For this we know a formula that DMA is equal to W into dx into x into L minus x bracket square divided by L square. Here this UDL is develop the fixed moment at here, that is the MA, and this will develop the fixed moment at B, that we call as the MB. So by the derivation, this small d MA, that formula is W into dx into x into L minus x bracket square. Now here, but we want this total integration from 2 to 6. So the MA, fixed end moment at A, that is equal to integration. Well, starting point is from here is 2. Now ending point is what? 2. 2 plus 4, that is the 6. And put here the W into dx into L minus x bracket square divided by L square. Now here this produces, this is developed is the Hawking bending moments, that is why here minus integration 2 to 6, W is equal to is 30, so place here 30, x into 8 is equal to 4 plus 2 6 plus 3 9 minus x bracket square divided by 9 square into dx. So this value becomes minus 136.29 kilonewton meter. In the same way, here DMB, small, if we consider here a small length dx, if you multiply this W into this dx, so this force is having this resistance x and this is L minus x, that we are taking here, and so this becomes W into dx is a load into x square into L minus x bracket square divided by L square. Now this is we have taken from this what? Anywhere if fixed beam is subjected to any load W, and suppose this is A and this is the B, so moment at A is equal to a WAB square by L square. From this you have taken this W means W into dx, this small W into dx into the x into the L minus x square, this is B square, this is the A and this distance is the B. So now here again same way is minus, because this MB produces, MB developed is the Hawking bending moment, that is minus, again limit is 2 to 6, here W is equal to 30 x square into L minus x bracket square divided by 9 square into dx. Now if you solve this integration, this value is minus 112.59 kilonewton meter. Okay, so we got the value of MA, we got the value of here the MB, fixed end moments here MB. Now next part is to draw the BMD. For that we have to first draw the free BMD. For free BMD we have to calculate the reactions. So remove the loads and consider the beam is simply supported like this. Suppose we consider for the free BMD, consider the beam as simply supported. Remove the fixity. This is 2, 4 and 3 meter, and this is 30 kilonewton per meter. Okay, so here first we have to find out the reactions. For that we know sigma MA is equal to 0. So what? 30 into clockwise, 30 into 4 into 2 plus, again half of this is 2. This is half is 2. This act at the center. So 2 plus 2, 4. Then minus this 9 RB is equal to 0. So here we got the value of RB is equal to 53.33. And by applying, if you apply the sigma Fy condition directly, right here RA is equal to, again the what? 66.67 kilonewton. Okay, so RA 66.67, then RB 53.33 kilonewton. Here this is kilonewton. Now next is to draw the free BMD for this simply supported. So we know here this is UDL, so this will cross somewhere. So again that is the contrast shear. So here first we draw the shear force diagram. First we draw the shear force diagram to know the where is the shear force is 0. So that again we got the point of maximum bending moment. So shear force at this RHS, okay, RHS of this A, from the left side we know this force is plus. So this is plus 66.67, and now this shear force diagram is constant up to this force, up to the starting of the UDL. Same way if we take the shear force at here from the right side, so from right side upward is the minus, so that is minus 53.33. Again this shear force is constant up to this point. Then join both these points. So this is the contrast shear, means where is the bending moment is maximum. So consider this is 66.67 and this is 53.33. Okay. Now suppose this point is the X, total is a 4, so the distance is 4 minus X. So here you have to apply the X divided by 66.67 is equal to 4 minus X divided by 53.33. Now multiply this into this, so this calculation becomes here the 66.67 into 4, this divided by 53.33 plus 66.67. So this point becomes 2.22. This X becomes 2.22 meter. Okay, we got this location, this 2.22 meter. So now here bend moment at A and B is 0. Then bend moment, suppose this point is C, this point is D, and this maximum bend moment. So bending moment at A and B is equal to 0. Then bending moment at C is equal to, at C is how much? 66.67 into 2. 66.67 into 2. So this becomes 133.34. Then bending moment at D is equal to, here from the right side, 53.33 into 3. 53.33 into 3. So this becomes 159.99 kilonewton meter. Here also write the kilonewton meter. Now bending moment max means at the contrast shear, this location. So suppose this location is this here, this point. So what is their bend moment? 66.67 into 2 plus this 2.22. So 66.67 into 2 plus 2, that is 4.22. Then minus this load 30 into 2.22 square divided by 2. Okay, into x by 2, like this. So this is equal to, here the calculations, 66.67 to 4.22 minus into 2.22 square. This becomes 207.42. Okay, so we got the bending moment at A, bending moment at C, bending moment at D, bending moment at B, and maximum bending moment. Now we draw the free BMD. Now at the C is how much? 133, somewhere here. Then at D is how much? 159 is, here is 159.99, and this is 133.34. Right here the kilonewton meter. Now at 2.22 at here is how much? Is 207 is somewhere. So enjoy this. This is 207.42 kilonewton meter. Okay, so this we called as a free BMD, and this is the, every value is the plus and plus. So that is the second bending moment. Now what is Hawking bending moment here? We should draw the diagram of Hawking bending moment. At is 136.29. 136.29 kilonewton meter, and 112.59 somewhere like this, 112.59 kilonewton meter. Now this diagram is the fixed end diagram. So what is here? Our aim is to superimpose this diagram over this simply supported diagram, so that we got the combined diagram. So superimpose this What is our aim? Superimpose this diagram as it is. Pick this diagram and keep on the here. So this is what 136 somewhere is here. So this is 136.29 kilonewton meter, and here is 112.59 kilonewton meter. Okay, so this becomes the, if you divide this like this, and like this, so this is negative and this part is positive, and this combined parts gets the cancel out. Okay, so this becomes the BMD, bending moment diagram. Now remaining is what? Shear force diagram. So for that, again, if you draw the beam like this, same beam, we got the value of here, this is 30 kilonewton per meter. Here this moment hogging 136.29, and this moment is 112.59 kilonewton meter. This is also kilonewton meter. This is the RA, this is the RB. Now again find the reaction considering this external moment. So sigma MA is equal to 0. Here this is minus 136.29 plus this is 2 meter, this is 4 meter, and this is 3 meter, plus 30 into 4 into 2 plus again this half of this is 2, so 4, then plus 112.59, then minus, we were considering upward here, so minus 9 RB is equal to 0. So here we got the value of RB is equal to 50.70 kilonewton. Now apply the sigma Fy condition. So we got here the RA is equal to 69.30 kilonewton. Okay. Now we got reaction RA, now reaction RB. So again we draw this beam, and below that we will draw the shear force diagram. Here this is UDL 4 meter, this is 2 meter, this is 3 meter. This got we RA is equal to 69.30 kilonewton. We got this 50.70 kilonewton. This is the moment 136.29 kilonewton meter, and this is 112.59 kilonewton meter. So now draw the shear force here diagram. So drop this point here, drop this point here. So we know at shear force at here is what? This from left side is upward positive, so this is the 69.30. Up to here this shear force is constant, and from the shear force at here from right side is the negative, so that is the below the line, and this is 50.70, and this shear force is constant up to this point. So this is the constant, then join this line. This is plus and this is the minus. This is the final SFD. Okay, and this is the final BMD. So our aim is to find the BMD and the SFD. So thank you.